Hello again. In the last episode we started to do biomes, and in this episode we're going to go ahead and try and finish it off. We may not be able to manage the entire, all of them, but we'll go ahead and give it a shot. So the first thing we need to do is we need to actually make it so that we can specify bricks in our biome. But this is actually a little bit more complicated than you might think, because these brick types don't come with any kind of value judgment. We don't know the role they play in the biome, and we don't want to just kind of lay them down arbitrarily. So we need to create a new kind of class, and this is going to be called a bricklayer class. And once again, this is not a mono behavior, it's just a class. And once again, it is serializable. So this bricklayer class exists largely to put bricks down in specific places. And how that works is that a biome has a list of bricklayers, and for any given tile it will ask for bids, and it will take whatever bricklayer has the highest bid. Public enum brick. Wait, it's not. It's public brick type brick. Brick. Yeah, there we are. And then we need to actually have a set of conditions that the bricklayer follows, that the bricklayer likes. So first off, we need to wait. But we also need to understand how the brick is laid down. And we're going to go ahead and make that another set of enums. Like this. And we can make these a lot of different things. So for example, none. We can also make it ground level. We can make it right now let's just go ahead and do a couple of basic ones with above ground level, below ground level. Later on we will polish these to the point where we may actually have several different classes of bricklayer will descend from it. But for now this will work fine, because that would actually be a little bit difficult to do in the inspector window. But we actually want an array of these, and the reason for that is because the more there are, the higher our maximum bid is, which means that if you have something that is at ground level and next to water, it will bid higher than something which is just at ground level. So we also need to get ourselves a bidding here, so public float bid, a public virtual float bid. And how do we specify the bid? Well, we do int x, int y, int z, but that's really not what we care about mostly. In fact, we don't care about x and z at all, because those are relative to the chunk, and therefore they don't make any sense to us. Y does, because we're not stacking chunks. In addition, what we would like is we would like to have the float mountain value and float, I forget what the other one's called, noise value or something, isn't it? Let's take a quick look. Blob value. Because it creates blobs. And we also need to have the chunk. For right now, we're just going to go ahead and do a quick little check for float bid equals 0, return bid times weight. Oh, if weight equals 0, return bid. And this is just because if we accidentally forget to initialize it, I don't want it to not count. For int a equals 0, a is less than conditions.count, conditions.length, a plus plus, and switch conditions a. Case none bid plus plus break. Case above ground level if we don't have any actual permanent definition for ground level as far as I know. So we're just going to give it an arbitrary value of 10 for the moment. Alright, so there we go. We now have a basic method of getting these bids. So let's go ahead and go back over into our biome and let's define ourselves a list of these. It should probably be brick layer with a capital L. Let's go ahead and change that now. There we are. And this needs to be capitalized as well. Oh, I should have... come on. There you go. Rename this as well here. There we are. Now we're all in the same camel caps. Alright, so if we go ahead and open up our camera and take a look, we can now see that our flatlands and our painted desert now have brick layers, as you can see. So let's go ahead and add ourselves some bricks. So let's go ahead and make this brick rough stone. Well, actually, why don't we make it dirt? And we'll call this dirt. And we'll make our conditions. Oh, look, it expands just fine now, doesn't it? Make one of them none, and we'll also make one of them ground level. And we'll make our weight 0.5. And then down here, we're going to make this one, how about dirty ice? And we're going to make the weight 1, and we're going to make this one above ground level. Now our painted desert, let's go ahead and do 2 brick layers here as well. We're going to have one of them be river floor, and that is going to be ice with a weight of 1, and the conditions of ground level and below ground level. And this one here we're going to have be boulder, and this one's going to be granite, and it's going to have a weight of 1, and it's going to be above ground level. Oh. There we go. The chunk height is 100, so let's go ahead and change our max height here to 90. There we go. So unfortunately, we haven't actually implemented those bricks here in our builder yet. So let's go over into chunk. Oh wait, we added here. So we need to go ahead and create a public byte get brick, and then it's got the exact same arguments that we use here. So what we do is we just go through each of these and we say brick layer best bid equals null. If best bid equals null, return 0. Else return best bid dot whatever brick. But of course, brick is not in a byte, is it? It's in an enum, so we have to cast it to a byte. For float bid, float best bid. Now, so this one's best bid, and this one should be best bidder. Float int a equals 0, a is less than bricklayers dot count length a plus plus. If float bid equals bricklayers a dot bid, y mountain value blob value chunk. and we say if bid is greater than best bid equals bid, and best bidder equals bricklayers A. So that just goes through all of our various bidders and gets the best one, and we get the best one back here in bid, and then world chunk actually needs to get that value. Here we do this brick equals 1. This doesn't happen. It happens down here. There you go. Oh wait, we don't want to... Wait, we want to do this before... Sorry, I'm thinking we want to do the mountain value checking before we actually do the turning it into a y value. And the reason for that is because the y value is modified so heavily that it ends up making the mountain value worthless. Or passing in the y value. We don't need to pass in the y value twice in two different forms. So we say byte brick equals biome dot get brick, and then we pass it our y, which is in fact our mathf.floor2int pos.y, our mountain value, our blob value, and our chunk, this. So let's go ahead and see whether or not that worked. Nope. Oh, it doesn't actually have the ability to... We're doing this with a static variable, so we can't pass it a chunk. Alright. We'll live. That may actually bite us in the ass later, because we were going to use that to pass in the map values, but I guess it doesn't really matter at the moment. We've got other things to do first before we even think about worrying about that. I know chunk doesn't exist, I just deleted it. There we are. Lava? I don't remember specifying any lava. So it's clear that it's working, but my brick enums aren't lining up with the actual texture that I was using, because I don't believe... If I pick this up, will it tell me? It won't actually tell me what brick I put down because I disabled that. Brilliant! Let's go ahead and re-enable that so I can tell what's going on. Crash! Picked up dirty ice. So that's supposed to be the dirty ice, but if we look at the textures we can see that it's actually... I don't have a texture that looks like that. No, I mean I don't have a texture that looks like that. Oh, it's being crammed against the right-hand side of the map. I get what I did wrong. Okay, so over here in chunk, when we are getting our x value, it should be right here. Here it is. Here we say UV corner x blah 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 blah. We actually need to do this as brick. Is it brick minus 1 percentage 8, or is it brick percentage 8 minus 1? Ooh, I don't know. Let's try it this way. Well, that seemed to work for the particular bricks I was using. There we go. So now we have our biomes. We may have a bug in that, which we'll find out if we ever use the 7th brick or the 8th brick. But as you can see, this all worked out fine. We now have basic biomes and such. Here you can see that we've got a biome that merges into another biome. Now I wouldn't call this blended because it actually just kind of cuts over into this other biome type, and then there's just this blob of this one biome, and then it immediately reverts back. So I wouldn't say that these are blended, but I might go ahead and tell you how to blend them, but it's really not that difficult. You just have to get two biomes and determine how much of one and how much of the other, and then just either weight everything or average everything. I think this is good enough for me at the moment. I may go ahead and add more biomes as I see fit. You are, of course, welcome to do the same. And as you can see, this particular approach has led to some pretty serious floating island problems, which maybe that's what I'll address in the next episode. But one of the cool things about this biome system is that because biomes can change in midair, you get these really cool layered biomes, where if it was all one biome, what I'm standing on now would be a blob. But instead, it's this neat carved out space because the biomes switched in midair. And that's because we use different wavelengths and different positions within our noise field, so they collide in fun and interesting ways. So putting aside the floating terrain, I think this looks pretty cool. And really, I do want terrain that is very vertical. It's just that I don't want it to float. Alright, so that's it for today, and you're welcome to play around with this. I'll include all of the textures and stuff in the download. So have fun.